All right, so this is a new piece of malware, and I thought this analysis is very nice. It shows the kind of analysis we do in the malware analysis class pretty nicely. And so there's this stuff that loads. It's a loadperf.dil DIL file, which is a legitimate Microsoft DIL that has something to do with loading the performance information, I think, into Task Manager. And so they have with the same name as a real DIL, but they'll put it in a different folder, I suppose. This copies itself into a folder and replaces the original DIL. So now you've got a poisoned library. Then it uses a legitimate service to import the loader into services.exe. And now you've got load oerf.ini. And anyway, once it gets loaded, here's the extra section, the kind of sections you'd see in, you're doing this in one of the projects in my malware analysis, like exploit development class, adding another section and hiding malicious code in there. And then it contains decryption, run, and code injection functions. So when it's loaded by the system, it automatically runs DIL main, which is what all DILs run when they're loaded. That decrypts the payload, and it decrypts it with a payload that depends on the machine ID, which I think is something like a unique identifier, sort of like an SID. So if you try to analyze the files this thing creates on a different machine, you will not be able to. You can only analyze them on the machine that's infected. And then it runs partial code, which is injected, payload is run into memory. It does a whole series of imports and so on, downloading more and more pieces. And then it uses GitHub as command and control. As you know, GitHub is where you put up your software and you can have multiple versions and keep updating the versions. So it goes to a GitHub page and it finds an HTML document and it loads it. And this is apparently a well-known encryption, a well-known file type, which I did not know, this DZKS thing. They say malware people use this a lot. This is plugx encrypted. So I don't know anything about plugx encryption, although it looks to me like a pretty good CTF kind of thing. And so this is not only encrypted with plugx, it is a modified decryption routine. And this will, when you're done, you get the command and control center. And off it goes. So here's the, it takes plugx plus shift plus base64 with perhaps XOR thrown on top of it just to scramble it a bit. And then it communicates with that machine, and here's the variety of command and control servers it keeps flipping through as they watch it pass through servers. You have to keep doing this. You have to keep moving your CNC servers because pretty soon people bust you. Someone analyzes the malware like this, and you have to move to another server. So anyway, that's the game. It's on the road. And the one thing I did not see here is exactly what harm it does, but it's under control, and GitHub is going to try and take it down. All right, anyway. But it's kind of cute, and that's the same kind of analysis you get if you just go through the steps you do in the malware analysis class to see basically what the server does, what malware does. Anyway, Google is going to make it so if you install Google Maps on your portable device, you can choose to share your location with your friends. So if you're wandering around a fair or bars or something, you can find people, which actually sounds pretty convenient. And of course, the dark side of that is this means the goal is to get everyone to turn this on all the time so Google knows what you're doing all the time. And they get this wealth of information because, remember, Google's mission is to index all the world's information. And that is the exact opposite of privacy, and they know that. And we got very upset when Facebook came out because Facebook created this important trove of data, everybody's Facebook posts, and who all their friends were. And every time they liked something, which is very useful data, and Google didn't have it, and they couldn't get it. And that's why they, a couple years ago, one of the CTOs made the bonus of everyone at the whole company depend on developing a social network for Google because they wanted to replace Facebook with an alternative so they could get all that data, and they totally failed. All their social networks are total flops. They don't even use Google Plus themselves anymore. They just gave up. But anyway, that was they thought it was super important to get into social the way Microsoft thought it was super important to get onto mobile. And they're probably both correct. But anyway, so Android's, apparently Android has improved their security. The latest security report apparently came out, and they said now half of the Android devices actually have security patches. Although I think the careful statement is half of the Android devices installed one patch in the year 2016, which is considered to be a giant leap forward, which it is. It is somewhat less terrible. So apparently they're having some success at creating a security patch channel that carriers allow through because they don't put features in. Anyway, and now they say instead of it being less than 1% running the latest version, it's now up to 3%. So, you know, Android security has gone from just a horrible and beyond belief to still pretty horrible, but a small step up. This guy has been arrested. He managed to perform 2 whaling attacks and got $100 million. Whaling is the big form of phishing. You send an email to the CEO saying, I am your business partner, please wire the $50 million we agreed to buy my company to this account. And a lot of people will just do it without verifying the email or anything. And you just have to write a moderately convincing email or just try until you hit someone who is kind of stupid. But this has happened to a lot of companies where they just email them and ask for money. And somebody in the financial department believes the email and sends the money without checking. And then they realize, we should have better procedures here where no large checks are sent out without actually making sure it's a real legitimate request. There's a drone shooting 4K as it drones around underneath the water, which sounds pretty cool. I just thought I'd mention this. This guy used to be, I think, the head of the NSA, Michael Hayden, and he's explaining what's going on with the latest testimony from Comey, and it's very interesting to read about this. And he said, I think this is a guy that's actually thinking very clearly. And so he says, it's a very good day for the intelligence agencies, the FBI and the CIA, because they have shown that when you just lie, like Trump does, saying that you've been wiretapped when you weren't, then they really speak up and push back and say, look, we know what's going on. We did not do that in clear terms. And the other thing he said, he points out something very clear. The Russians are playing us like a fiddle. They are outsmarting us in the intelligence game very well, just like Osama bin Laden did. Osama bin Laden wrote 10 years before his attacks, I've got it all figured out. I'll make this attack. They will spend trillions of dollars running around like scared little children because they have no God and they have no backbone. And I will mess up their whole culture with just a few targeted attacks that will cost me very little. And he was entirely correct. All that happened exactly like he said. And the Russians also know exactly what they're doing. They're destabilizing our democracy and making people not trust the government. And they did this by hacking the Democratic National Committee and then passing it through their stooges, WikiLeaks and DC Leaks, which may not be directly on the Russian payroll, but they are what you call useful idiots. They are stupid enough to use anything you hand them. And they say covert influence campaigns work best when they exploit existing fractures in a society. So you just find where they're weak and make them weaker there. And they say it's not only messed with your heads, they also put their thumb on the electrical scale to some extent, and on it goes. So it's I'm impressed. The Russians play dirty, and they're smart, and they're getting exactly what they want. They're playing us like a fiddle. We are helpless against them. There is a weakness in the American character that is very clear to our enemies, and they're good at exploiting it. Anyway, so we're down to the chapter, if I can find it. Should it be open somewhere? A pill doubles your IQ? That's gotta be garbage. Doubling your IQ is insane. It's a statistical standard deviation scale. That can't be right. And I don't think Stephen Hawking would say something that stupid. Adding 10 points to your IQ is what people mean when they say they're doubling it. Anyway, so so that's probably complete nonsense. But if it isn't, then a journalist distorted it beyond recognition. Anyway, we're up to this chapter here on OAuth through SAML, which is really important. And I was just thinking today, I think I want to make another addition to the wall of sheep at DEF CON. I want to take, you have the project where you make an SSL auditing proxy, and it does a man-in-the-middle attack, and you see if your mobile devices are using insecure SSL. That could be a gadget just running at DEF CON, where you go connect to the network and see if your passwords appear on it, and I think it should be. I think I'm going to try and have that automated so people can have it at the wall of sheep at DEF CON. Because the problem here is there are perfectly good systems to use to avoid exposing your password, and people just don't use them. Because consumers don't have any way to audit their products to see if they're actually obeying any good rules. So why should the manufacturer bother when it's just cheaper to do everything wrong and the customer can't tell? So I'd like to increase awareness of how easy it is to audit the security of your mobile device. So anyway, so just for background, there's server-side technologies which are where a lot of the risk happens. So SQL, you already know probably from the other classes. SQL, you send things like select star from table to get information. And this is the way most data is probably really stored in large databases like insurance databases and government databases and such. But there are a lot of other formats used to store data, particularly for mobile apps. And there was a whole movement towards NoSQL databases that stored it in a different way. And now that seems to have fallen out of favor and people are pretty much moving back to SQL type databases. And so SOAP is middleware which moves data between servers and clients, and it uses XML. And it can move over any protocol, even SMTP, which is kind of insane, where you email the request and it emails the reply. That seems very strange to me. I don't know why anybody would want to do that, but apparently you can. Anyway, so this is what a SOAP request looks like. It's very much like an HTML request. So if you want to put something up, you post. This looks just like an HTTP request, but down here it's got XML. XML is the general category of languages that includes HTML and other languages. So it looks like HTML, but it has more general tags. You can have any kind of tag you want as long as you have a closing tag somewhere. And that's what it looks like. And so if you send a request with a GET, you'll get a reply with an HTTP status code, and down here will be a bunch of XML encoded stuff with these SOAP env tags. There's an envelope tag and there's other tags inside there. And it's just a way to organize data so you can send it up to the server and it's labeled, so it's structured. This is the name, this is the address, this is the phone number. That's all it is, just some way to format the data to send it over the network. But you'll see this if you're looking at traffic coming from mobile devices. And then there's two general ways to store data, common, JSON and XML. JSON stores them as a JavaScript object. This is just the format for a JavaScript object where you have these braces around it, and then you have a name, and then you have a brewer, which is a container that contains 2 parameters, and then you have a couple more parameters down here. That's how you can have a tree-structured group of data put together in JSON, and it could just as well be an XML, where beer and name and brewer then has another name. So this is the name of the brewer, and this is the name of the beer, and they're kept separately by how many levels they are deep in the hierarchy. They both amount to the same thing, but those are just common ways to format data, and you should be aware when you look at mobile apps and mobile devices, you'll see all these things flying around, and often in the same app, more than one of them, as it connects to one server and some other service. All right, then there's REST. REST is this screwy stuff where you put data in the URL that I would think would be more logically put in a parameter. So the URL appears to have a folder and a subfolder, but those are actually parameters just stuck in the URL. So it's using HTTP. You could interpret the web as a REST-based architecture, so you send data up with put and get it with get. The example I found used the curl command, which is the Linux command line tool you can use to make these requests. A more familiar look to us is probably the way they look in Wireshark, catching them on the wire, but this just shows the same thing. You have to have a username and password, and then you send data, and here is that data in what looks like JSON format to me. And here you've got the server and the port, and then you've got things here like V1 documents, and those things might or might not be folders. They could also be parameters that are used at the server. But anyway, these are minor variations on good old HTTP, but that's what mobile device uses, is largely these techniques. And there's JSON again, showing another, it's considered lightweight, an alternative to XML. It doesn't make a whole lot of difference, but anyway, these are things you'll see. So if the server has a flaw, like a SQL injection, that is probably much more dangerous than a client flaw, because the client flaw typically only exposes one customer. A server flaw typically exposes them all. This is where I deal with a lot of people ask me, I'm safe because I don't use online banking. I carry my money to the teller, and I say, that probably doesn't do any good at all, because the main place that's getting stolen is from the bank, and at the bank, somebody types it in and puts it in a computer, even if you don't. And you have decreased some risk, but I doubt you decreased the largest risk by that practice. But it is a thought. And of course, the server has a larger attack surface. It's up there all the time. It's running many services, has business partners, and all sorts of exposures. So it's logical that there will be errors found in those, and people will be stealing things, and that's what we see. I think one of the big scandals last year was the failure of SWIFT, which is the bank system used to move vast amounts of money across nations, and it turned out to be completely vulnerable and hacked, and people stole $100 million from another nation, I think Pakistan or something. And then, was it Bangladesh? Yeah.
It seemed like it's taken by one firewall.
Right. And so the whole protocol used and trusted by the banks for their largest transfers turned out to be woefully inadequate, and they had to rush out and update to it. Anyway, yeah.
What was the other one, a big bank they stole a few million, like hundreds of millions of dollars, but they were able to trace them and get most of it back?
Yeah, that was SWIFT.
To get like $1 billion or something like that?
That was the SWIFT hack. The SWIFT hack, they tried to get $1 billion, and somebody managed to detect it and stop most of it, but they got some of it. Yeah, and this is quite common. And one thing people may not know is that if you are an individual and the bank loses your money, you get it back in America up to $200,000. But if you're a business, you're not covered. There's even been a case that went to court a few years ago where a bank required people to use an outdated version of Adobe Acrobat Reader because they wouldn't bother to update their stuff. This guy got hacked through the reader. They stole his password, logged into his account, and stole his money, and the bank refused to pay anything, saying it was your responsibility to secure that, even when they made it impossible, and the bank won, because they do not have any obligation for the security of business accounts the way they do for consumer accounts. Anyway.
So do the business have extra insurance for something like that in case that happens?
I don't think they did, but I guess they should have. That's what you got to do. Anyway, so then there's the OAuth Top 10 Mobile Risks, and this was just updated last year. So these are good to know, and they overlap somewhat like they always have, but these are in order, the most important one going down. So the first one they like is improper platform usage, where you just don't use the technology that you're supposed to use correctly, like you send Android intents that have confidential data in them, put things in the log, foolish things like that. Don't correctly use the keychain on your Apple device, but instead put the password somewhere stupid. These are failures to use the technology that you're given. Then there's insecure data storage, of course, where you put data in plain text, or you in someplace public, or you put data somewhere where it's going to leak out and easily be stolen. Then insecure communication, like using old SSL versions, not verifying the certificate, sending clear text communication when you should be encrypting it over networks. Then insecure authentication. This is when you don't keep track of who people are properly. This is very common, for example, on router control panels. If your Linksys router and such often has a page that does administrative function and it does not really force you to log in first. So you either fail to identify the user at all when it's required, or you don't keep track of the session or the identity correctly, so it's easy to trick it into thinking you've logged in when you haven't. And then insufficient cryptography. This doesn't apply to complete plain text, but it's the term for people who apply cryptography incorrectly, which is extremely common, and that's why I decided to teach a cryptography course, which we'll have next semester, because it is actually sort of difficult and hard work to use cryptography correctly. There are a bunch of things you have to do. And an incredible number of people obviously just take staff that has not been trained and tell them encrypt this stuff by Friday, and they just take some math book and try to do it, and they don't really know what you got to do, and they get it wrong. Like we saw Stitcher using the Caesar cipher. I found a bunch of what Staples uses a password that is just your device ID. Another app I went to uses an AES password that is the last 8 characters in copyright parentheses 2013 parentheses. Just stupid, predictable passwords. A bunch of things use electronic codebook mode, so the encrypted ciphertext contains patterns from the input, and it's very easy to seek out the key. You know, it's just amazing. If you just try to do encryption and you never tried it before, and you only spend a couple days on it, you don't get it right. It's more complicated than that.
I saw some new routers they sell.
Yeah.
The password is that's on the side.
Mm-hmm.
You can figure it out from the information it transmits online.
Yeah, there's a whole bunch of brands like that in Europe that have been out for years, where the actual MAC address is used by running through something foolish like one round of MD5 and take the end of it, and that's the SSID.
It's just part of they take a piece of this and a piece of this, but together that's the password. It's
That's right.
Clear text.
That's right.
Yeah.
Yeah, and so there are a bunch of tools you can download online where you just sniff it, take out the MAC address, put it in, click go, and it tells you what the password is. Yeah.
What I saw was a router that had a sticker on it. And
Yeah.
It
Yeah.
had SSID and the MAC and the
I think
password
it's
for
what I
admin
talked
access.
about,
Yeah, well, now that's not necessarily wrong, right? You could take off the sticker if you hear about security, this helps you, you're not going to forget it, as long as they're not mathematically related.
Well, they actually were exactly the same. So
Well, yeah,
if
that's-
you have the MAC address, then
Yeah.
it's trivial to get the password.
Yeah.
And if you just have the SSID, then you only need to guess maybe 2 or 3 additional hex characters. So
Right.
there's only 16 options for each to basically get in. So the SSID itself is leaking the password to log in unless you change it.
Yeah, and essentially the whole world does that when they invented Wi-Fi Protected Setup, WPS. I first heard about WPS by reading Microsoft manuals, and they said Wi-Fi Protected Setup means you don't have to type in the password, it'll automatically transmit the password to the other devices. And I said, of course, this is a security benefit because the password is no longer going to be a simple English word, but what they didn't tell me is the password boils down to an 8-digit character, which is 2 4-digit numbers, and the last one is a checksum calculated from the rest, so there are only a total of 10,500 possible values, and you can just brute force them all. And that's another example. You have a system, and then you choose to implement something. They they wanted to have a number they could put on the side that wasn't too hard to type in, so they undid all the benefit of a system that automatically moved it so we wouldn't have to be simple by making it simple. There's a lot of this. Like there's websites that will only let you put in a 6-character password, only let you use letters and no special characters and foolish things like that. Then it's insecure authorization. This is where even after they figured out who you are, they fail to implement authorization. For example, they might not have any permissions set on the folders, so that even though you are not logged in as root, you can wander into folders you shouldn't be able to get into. Then there's client code quality, security decisions via untrusted inputs. This is a catch-all for foolish mistakes. Things like buffer overflows, format string vulnerabilities, when you have just written code that adds new vulnerabilities of its own. And code tampering, this is what we're doing in the projects in Android. When you download, take an app, suck it off the phone, modify it, put it back on the phone, now you have a poisoned app. And there are defenses. You could put in your app so that it will not be easy for a reverse engineer to modify it, and so that when it connects to the server, it will detect that this code has been modified and refuse to talk to it, and that's what you should have. Reverse engineering down here is similar, taking the final binary and figuring out how it works with IDAPRO and Hopper and such. And then extraneous functionality is, of course, apps that contain Trojans. And this is big in the PC world, and I think it's true in the Android world too, that you can download an app and then you can download another copy of the app from another source that has added extra Trojans to it, like browser hijackers and things that pop up ads and junk in the app. So that's a pretty good list of the things to go wrong. And it really would be nice if customers could expect that you're not going to do these 10 stupid things when they get an app. Yeah.
Something interesting that happened in China was for iOS, there was basically someone sharing Xcode on a Chinese server.
Right.
That Xcode had some kind of malware in it that added stuff into every single app that was compiled. And so just because people downloaded this Xcode from another source, they had a bad version that added stuff into their app.
Yeah, that's a huge one. So, and that's what they worry about. That's supply chain management. That's why a hammer costs $700 for the military, because it's not enough to just build something. You have to prove that all the things you used to build it had actually been audited and filed a form saying they were audited, to make sure you're not taking some cheap thing from China and using it to build your device. It is a big issue. All right, so I got a few iClicker questions about that stuff. Come grab one if you need one. I think we will not have to try to read the MAC addresses off the iClickers this time. I supposedly fixed that problem. But we will see. As you know, technology tends to fail when you need it. The Windows version of this thing, when you create a class, puts it in the wrong folder somehow. Anyway, I had to move the parameter file to a strange place to get it to work. But theoretically, it's working. But this is PowerPoint. All right. What's the server-side technology that runs the web? This I'll quit at 30, and I may only have 8 participants. All right, that's REST. Okay. Well, no, the part that's called the World Wide Web is just what they call REST. The World Wide Web is just the assemblage of pages you can see in a browser. It doesn't mean all the traffic on the internet. And the rest of these technologies are not used that much to serve up normal pages in a browser. All right. That's a statement made in the book. I can see how one might possibly argue about it, but anyway, let's charge ahead. All right. Which one operates over any transport protocol, including SMTP? This time, I think there's only one clear answer. And for me, the missing ingredient is why would anybody want to do that? But anyway, apparently somebody wants to do that. I'll quit at 30. All right. And that's SOAP, I think. Yeah, it looks like that's SOAP. All right. Simple Object Access Protocol. All right, what's going on here? one of the very famous XKCDs. There was at least one major company that fixed their security because of this cartoon. The manager read it and then talked to the staff, and they realized nobody had thought about this. All right, I'll wait till 35. That's SQL injection with a name like this, Robert's quote, parentheses, semicolon, drop table students. That's SQL injection. All right. All right, Obama's campaign forum was hacked by putting a script tag in a comment. What's that? That was when he was running against Hillary in the primary in, I think, 2008. I'll quit at 30. All right, that's cross-site scripting, where you add script tags in where they're not supposed to be. So they execute in a place the developer did not intend to have them execute. All right. A Stitcher uses HTTP instead of HTTPS. Which phone is that? All right, I guess I'll quit at 25. Looks like the answers are in. All right, that is insecure communication. Now, by the way, I don't know if I told you, but I'm always testing mobile apps to see what's wrong with them, and I found a Kaspersky app that uses HTTP instead of HTTPS. And I said, Kaspersky did something wrong? I said, rather than going straight to the press, I said, this is really hard to believe. So I tried sniffing passwords, and it was encrypted like Stitcher with something inside the HTTP. And they had a bunch of back and forth going on, and I said, I can hardly believe they're dumb. I wonder what they're doing. And I researched, and I found their white papers explaining how they have invented their own version of RSA encryption that goes over HTTP, and they think it's better. And over HTTP, it is distributing a certificate, distributing a key, arranging all that stuff. And I'm not inclined to say I'm smart enough to know they're wrong. It's a strange thing to do, but I wouldn't say they're not encrypting it. They're just not using the expected kind of encryption, and they replaced it with their own, which they have complicated mathematical arguments claiming it's okay, and I guess it is, yeah.
But why?
That's a good question. I don't know why, but for some reason, maybe they really don't trust the certificate chain or something. Anyway, they chose to invent their own version, and they use it, and it's not like it's not encrypted, and I'm not going to put the work in to try to dig through all their stuff and find what's wrong with it. I imagine they did their math right, because they're pretty serious people. Yeah.
Encryption is one thing, though. The other thing is authentication, to make sure that you're talking to Kaspersky, not someone else.
Yeah, and I wonder how well it, I don't know how it does that. I wonder. It might be, I think it was some kind of like cloud backup, so maybe there's a shared secret. I think it's only, that's a good issue, I know. That's why, but I mean, the question is, how much do you hate PKI? And a lot of people really do hate PKI, the public key infrastructure. This bunch of certificate authorities handing out certificates. You know, there are people, for various reasons, that just don't like that system. Yeah?
So they could always use HTTPS as everyone else, and then inside of HTTPS packets, they could do whatever they want.
They could.
Like, they could still be using HTTPS.
You know what it was? I watched the updates for Kaspersky's products do not come in over HTTPS. That's what really blew my mind. I said, holy cow, that's like a classic mistake, but they do have this other system. So, yeah.
Apparently F-Secure is doing updates over HTTP also.
Yeah.
And I don't know, however, if they're...
I know, at first that sounds terrible, but then you wonder, did they have some reason and put in some compensation for the obvious risk? But yeah, I know. I know Ubuntu did that. Ubuntu had updates over FTP that were not authenticated, and then they let amateurs set up clubs and run local servers, and they actually did get poison updates. Because people put up like FTP servers with default passwords, and people were getting updates from those things, and there was no integrity control. It would have been safer to just use BitTorrent, for example, that actually has hashes, and you know if the file you're getting is the way it should have been. Anyway. All right. There's one more of these. So Stitcher also uses Caesar cipher instead of RSA. Now, what's that? All right, I'll quit at 25. Now that's, of course, insecure cryptography. You have attempted to encrypt it, but you've chosen a really foolish method that's not strong enough. All right, so let's see, 6:30, good, we can just carry on here. So let me go to this thing here. And all right, so XML-based web services. So if you want to do a security audit, you find the endpoints, look at the source code, or watch the web traffic with something like Burp or Wireshark. Find out what kind of traffic it sends to where, and then you craft legitimate requests and send it in to see what it does, and then you try various attacks on it. You go all through the structure of the XML to see if you can fool it. So one good place to start is the WSDL file. You'll typically have this file on the server, and it specifies what services we have and what format the request should come in. This is sort of like the endpoint mapper for remote procedure call in Microsoft, where you send a request and it tells you what services we offer and what kind of data you should send if you want to get services from all those. So SoapUI is a product that will read the WSDL file and then build requests in accordance with it to make it very easy for you to make your own requests to test software. So here's some of the attacks you can try. So if suppose the client sends something to request a product, like order a product, and there's a product ID in there, and the server replies saying, okay, here's your price. You ask it, how much does this thing cost? It tells you the price. But it turns out that the server takes this number from the client and just repeats it. It doesn't validate it on the server. So that means all the client has to do is send an ID number that contains XML tags. And when the server just echoes it, your client will now get product response. You'll get an ID and a price, and then another product response with another ID and another price. And now it's not clear what's going to happen. This is there's a general version of this called HTTP response splitting, where you put some HTML tags in like your user agent, and when the server replies, your browser will get something that has 2 web responses instead of 1. And the most common thing browsers do is they just take the first one and quit. The first one has like a link to tell you how many links are in there. It just ignores everything after that point. So the most common thing is the injected one will be accepted as true and the other one will just be silently discarded. And that makes it easy, but you never quite know what's going to happen, but it's certainly an issue. So if you want to block this, you have to block special characters like less than or greater than, and the best thing to do is to use whitelisting instead of blacklisting. Blacklisting is where you try to list all the forbidden characters and block them. Whitelisting is where you list all the acceptable characters and take nothing except known good characters, and that's much safer. You can also do output encoding, where you take those special characters and turn them into HTML encoded characters, which will not be interpreted as the start of HTML tags, but they will just literally print that on the screen. And that also means that scripts won't run and blocks most of these attacks. It would be a wise thing not to write your own validation code, but just get it from OWASP. OWASP has libraries of code that have been written to filter out all known attacks, and that's what they're there for. In general, whenever you get to the security part of your app, you would be a whole lot better getting a library and reading the manual and using it rather than trying to write it yourself. But anyway, this is a screwy one. There's an old-fashioned denial of service attack called a zip bomb. You can zip a file. If you make a file that is really, really boring, like just a long chain of zeros, you can take like 100 megs and it'll zip down to about 3 kilobytes, because all it has to write down is 100 million times 0. And so you can make a zip file that is incredibly small, but will get big when it's expanded. And if you maliciously craft the zip file in a binary editor, you can make a zip file that will expand to some unthinkable size, like 1 billion gigabytes or something, so nothing could possibly unzip it. And if you put that file on things, then what happens is, when someone runs a forensic tools unzip files to check them. It'll crash the forensic tool, like in case. When the antivirus tries to scan it, it will also try to unzip it and crash, and a whole lot of things will just crash and die because it will try to unzip that file. And fine, this is a similar kind of attack. You can make an XML entity which cannot be parsed because the parsing makes it very big. So here's an example, a 662-byte request that expands to 20 megabytes. And so what this does is you define something called an entity. Is like a user-defined variable. So A1 stands for this sentence, I've often seen a cat without a grin. Then you have XML that includes ampersand A1 semicolon. So remember the ampersand LT semicolon is a less than sign. You can design your custom HTML encodes this way, and so this will turn into that. And that's fine. So it will expand that one and put that sentence in there on the server. So the parser that reads this in XML and checks the format will replace this with the text it was told to put there and turn it into this, which is what parsers are supposed to do. The problem is you can nest these together. So I can define A1 to be this sentence about a cat, and then I can define A2 to be two A1s, and A3 to be two A2s, and A4 to be two A3s, and now it doubles every time. So after 10 doubling it's 1,000 times bigger, and after 20 doublings it's 1,000,000 times bigger. So you can make something which is in itself not very big. It's just a couple of hundred characters, but when interpreted at the server, it swells up into some monstrous size and wastes a lot of resources on the server. So that's a simple denial of service attack. There's a bunch of these. There's you can do a very simple denial of service attack against an HTTPS server by just making a lot of requests and forcing it to do a lot of encryption and use up CPU time. There's just lots of cases where you can make a small request that causes the server to do a lot of work. This is in general called Layer 7 DOS, and there was a company a few years ago in Israel that showed that they could take down almost any corporate server with this, anyone they tested, because what you do is you hunt through the web page for something that is expensive for them. Like you find a search engine that doesn't go to Google, but it's their custom search engine. You find a query that will have a lot of results. You find some way to set it so it'll show me the first 1,000 hits instead of the first 10 hits, and then you just send that query as fast as you can, and that will really bring them down with maybe just a few requests per second, whereas simple SynFlood or something wouldn't, because they'd have defenses against that. And this is in the same category. So you can disable these document type definitions if you're not using them. That would be a simple answer. You can set a limit on the depth of the nesting that you allow. And phones, by the way, have these things too. And as you might expect, the iOS parser is protected, but not the Android one. At least at the time your book was written, which is now a couple of years old. Okay, then there's another thing, which is more than just a denial of service attack. I've talked about denial of service attacks, and you always get sneers from the pen testing community because they're useless in a pen test. In a pen test, you want to get domain administrator. You don't want to just freeze things up, so they kind of sneer at this as like pointless violence. But it is part of one of the risks we want to stop. Anyway, here you're going to try and read a file. Now, it turns out you can define something that is defined in terms of files on the server. You can define a thing called doc type, an entity called file context that points to a file on the server. And if there are not permission structures in place to block this, like there should be, it will actually put the contents of that file in the element, and then down here the parser will put it in for the file contents, and you'll see the contents of that file. There's an endless chain of these vulnerabilities. ASP had one a while ago where you could just put a $$ data at the end of an ASP request, and it would show you the source code of the ASP file on a Microsoft server. It's quite common that some file on your web server is exposed to the world, so you shouldn't put any file on a web server that is private. However, there are some files that are intrinsically private, like the password to the web server itself and such, and you don't want people getting them. So if you support these things, if you support external requests, you can even request it from other servers. The only thing that stops this is file permissions. And if your web service runs as root, it typically can read every file. So you can create a DOS if you want to by just making it fetch a special file, device file like the entire raw hard disk or something. Or you can just force it to make a lot of requests and use up the network connection pool with internal connections from one server to another so it can't service clients anymore. And if you don't like this, you could disable them or allow general entities but prevent the processing of external entities, or set up a resolver object so you have a whitelist of resources and nothing else is accessible to it. These are things to do, just people may not think of it. And of course, you can attack phones too. Android is vulnerable with their parser, and the iOS parser is safer, but a developer can choose to turn on these dangerous functionalities. All right, I got a few more iClickers, and then we get down to OAuth, which I think is the main event. All right, which item changes special characters to things that start with ampersand. All right, I'll quit at 30. I think there might be 8 votes. All right, and that is output encoding. It's HTML encoding is what it's called. Encoding special characters. You can encode any character that way. You can even put in ASCII numerical codes and such. All right. All right. which item will describe the functions offered by a web service. All right, I'll quit at 30 or 8, whichever comes first. All right, and that is WDSL, Web Service Description Language, something like that. Is it WSDL? I think that's wrong. I think it's WSDL. We can go. Just a moment. I have spelling failure. WSDL. That's what I thought. DSL, that's probably why I did that. WSD. Now I feel better. All right. Anyway, all right. So, all right, which one allows access to sensitive files on the server? All right, guess I can quit. That is entity reference down here. All right, you refer to something in another file and you define it and then you can see it. All right, which one uses a stolen cookie? These are general web attacks that you ought to know from other classes. They assume you know it in this chapter. From sort of Security Plus. All right, and that's cross-site request forgery. You take a token and use it in some other context. Not expected. All right. Which attack causes a client to see a strange response combining two responses? All right, I'll quit at 8 or 30. All right, and that is entity expansion. I think it was just plain old XML injection. Just plain old XML injection is how we did that. You don't need anything fancy. You just put in a bunch of extra XML tags in the parameter that's echoed back and cause it to look like two responses. All right, let's go on. All right, so let's talk about OAuth. OAuth is super important and not used enough. Okay, the point is, typically you've got a password to authenticate yourself, and the mobile app does too, but the users don't want to keep typing in the password. They will just throw away your app and get some other app if you bug them too much, asking them to put in the password. So the app apparently has to store your password and keep typing it in for you, which is obviously unsafe. So there are solutions available. One is a secure element, of course. You can have a special chip just to store secrets that is very hard to steal the secrets from, and that's what the secure element is on the iPhone. And I've been told, I think a couple of the very latest Androids have a secure element, but most of them don't. So that's the plan. That's one good solution, but the secure element is not available for most apps. Apple restricts its use to only their internal app and only for Apple Pay for credit cards. So most apps can't put their stuff there. So another thing you can do is have some kind of authentication framework. Yeah?
I think that's no longer true. They opened it up, so
Did they?
You can basically have your own keys protected by the secure enclave.
Oh, that's great. If you can store your secrets on the secure element, that would be considered a very good way to do it. Good.
Now,
Yeah.
just one more thing. So you actually can store the secrets, but what happens is that it has a special key that you cannot get out, and then that key is used to encrypt the secret.
Right.
Unless you can access that key by using the secure enclave, then even though you have the data, it's encrypted, you can never get it out.
Okay, that's good. And I think that's more or less how Keychain works too. But I think Keychain did not used to be connected to the secure element. Maybe it is now.
The reason that's important is because there's no storage limit. You can actually store the data in it, but you just encrypt it, and then you cannot decrypt it unless you can access it to get the key.
Yeah, a very good point. Thank you. All right. So anyway, OAuth is a system that prevents your app from having to handle the password. What happens is the user sends the password to a server, and the server replies with a token, and your app stores the token. It's like a cookie. And the point is, this would all be of no importance and amount to the same thing except for password reuse, which is basically ubiquitous. Something like 95% of all people don't use a password manager, so they have 5 or 6 passwords that they reuse everywhere. So getting someone's real password means you can get in all parts of their life that you shouldn't be. If everybody just used a different password at every service, there would be no actual benefit to this, except for the possibility the token might expire faster than a password login. But since people do reuse passwords, taking someone's password into your app is a responsibility that you really would not be willing to take if you understood the consequences. And your token can be made weaker. The token can only do certain things on the server and have an expiration date, and you can revoke tokens that are compromised. In your book, they recommend for financial apps, they shouldn't be storing any token at all and force the user to authenticate. I don't know any app that does that at all. I've been through a lot of financial apps. They don't obey any of these rules, but they should. And sooner or later, they'll get sued and embarrassed enough that they'll be forced to, maybe. Or we'll all just get used to such low security with the Internet of Things that we'll forget we ever cared about it. But anyway, in America, our credit cards are completely insecure with just a number that someone can record and play over and over and over again. And they've been that way for so long that the American financial system has adapted to putting all controls on the server side, identifying suspicious transactions, and permitting the end use to just be totally unsafe, which is why we switched to chip and pin without pin, so it's not any safer. In America, which doesn't make any sense at all, but you realize what we've been using all this time is you just hand a book of blank checks to everybody you do business with your credit card. They can just keep taking money forever. It's incredible, and yet the total amount of fraud is only 0.5%. And it's all done on the server side. They just treat us like idiots. We just do throw your money around like nothing, and we protect you at the other end. Anyway, so OAuth 2 is the current system used by all the big companies. This is the cool way to do it. So now if you want to access protected resources on the server, you can get to them without having the password into the system. Microsoft has their own version list called Federated Identity Management, which lets you, the classic case, Microsoft's internal systems, they had their people are working and logging into domains and getting into shared folders and SharePoint and all that jazz, and then their payments, like everybody in America, are processed by ADC, Ross Perot's company. So all the financial stuff is over there. So when it comes time for them to get their W-2, every Microsoft employee had to make a second account over at ADP and log in to get their W-2. And Microsoft said, this isn't right. We're going to put a federated identity management server inside our partner company, ADC, so that the Microsoft domain credentials will be accepted there and you won't have to log in again. And they got that all working, and it was awesome, but then they had the first round of layoffs at Microsoft, and a bunch of people got laid off like in November, and when it came around to April and they wanted to do their taxes, they couldn't log in anymore because they couldn't log into the domain. So there's always a problem that you create every time you do this. Anyway, so here's the players here. The resource owner is the human trying to use the app who actually owns the protected resources, and they would like to believe that they are getting at the resources and that nobody else is getting at them. Then there's the server, which is hosting these resources and taking some kind of credential information to make it believe that it knows who it's handing them out to. The client is the app. That is, and the server is the other end, the server that provides the app with the access tokens after you've received credentials. So there are 4 kinds of grants, and it seemed to me like the book did them in illogical order, so I moved them. So it goes from simplest to most complex. What the book did was put the most popular one first, which is, you could argue. But anyway, so there's 4 different ways to do this, and the user agent here is a sticking point, and I've found in Android and also an iPhone app recently that has the problem of using a custom user agent, which exposes all credentials to theft. Well, more about that. So here's the simple case. This is the case where you can use OAuth in a mode that basically turns off all the value of it. So your app stores the password, and every time you log in, it gives them the password. Then it gets a token and you can use the service. Next time it just puts in your password again. You're storing the password on the client. Now this is crazy and only recommended if the client can actually be trusted with a responsibility like that, like it has a secure element. You'd want to have something like that if you're really going to believe that that's a secure element. And I suppose this is probably good for like embedded systems, like your air conditioning unit or thermostat or something, where you're really not expecting anyone to steal it or hack into it. I don't know. Anyway, that's the simple case where you get essentially no value out of OAuth. All right, so that should be avoided unless your app takes some additional steps to protect that, like making a user put in a password just to launch the app, so the app can then decrypt the stuff that's stored somewhere. All right, then there's this one, which is a small step up. The app handles the credentials but doesn't need to save them. Every time you want to get in, it asks the user to put in a password. The user puts in the password into the app sends the password up to the server and gets a token, and the app doesn't keep the password. This is when Hushmail was had a scandal that made people not trust him anymore, and LavaBit had to shut down because the NSA demanded all the data about Snowden, and they'd rather shut down than give it. The guy that made the LavaBit encrypted email made a new service. I'm pretty sure it might have been confusing it with somebody else, but he made a new service, and Moxie Marlinspike had an interesting argument with him. Moxie Marlinspike's one of the smartest cryptographers in the world, and he asked him, you've got a server, you've got the email. He said, do you have the key? Because in PGP, you make your key, you store it at your end, nobody else on earth has it, nobody can read your stuff except you, unless they actually break into your house and steal the key off of your machine. That's why it is very difficult to use, because you have to somehow make sure you always have that key, and that's hard. I can't even remember where I put my stuff. So but that makes it safe. And so you ask them a simple question, do you have the key? If I put a gun to your head, can you decrypt that stuff? And the guy said, oh, the key comes in and we put it in a special memory structure and then we delete it. So you have the key. No, we don't have the key because we only keep it for a microsecond. So you have the key. No, we don't have the key. Dude, it's a yes or no question. Do you have access to the key or not? And the problem is you do. And the other problem is you're too stupid to understand this question, which is not good if you're going to run an encrypted email service. But anyway, that's the issue. The app does handle the password, and therefore could, in principle, steal the password. So that's kind of a problem. So we can do better. Anyway, if you trust your client not to leak credentials, then this might be all right here. It's better than storing credentials in plain text, but it's not a whole lot better. This is the one that's mostly used. So you decide, you open your app, like Facebook. I want to see my Facebook. So your app goes to the user agent. It says, well, I'll ask the user for a password. The user gives them a password. Then the user agent, not the app, sends this out here. Now, sends the password to the server sends back a token, and the app gets the token and uses the token to access Facebook. So the app never even sees your password, just the user agent. Now, the problem is, the smart thing to do and the secure thing to do is your app should call the default browser, like mobile Safari, to fetch the password and send it up, because mobile Safari is quite secure. It's attacked all the time and they patch it a lot, and the Android browser is pretty good too. The problem is, this is not a pretty user experience. Your brand name will not be here. This will really be the browser popping up, just the ordinary bare browser. So a whole bunch of apps like the West Point app and the Naval Academy app and all the cool, whole bunch of colleges I went to, will instead write their own user agent code in their app so they can keep their branding outside it and make it look like it's still part of my app. And then you have crushed these two into one agent, and now you're handling passwords, and that's what I found was all those devices were leaking all the passwords in there. Like the app would leak not only your college password, but your Facebook, Twitter, Gmail, and Microsoft passwords, because it connected to social networks, and instead of doing it with the built-in browser, it did it with your crappy, poorly written browser that didn't validate SSL. Yeah.
So it shows unencrypted passwords if
No.
it leaks, right?
Well, no, probably not, because most servers won't hand them out unencrypted. But what these did was they used HTTPS, but they did not verify their certificate, because they wrote their own browser in here and they didn't bother to implement that part of it. And the problem is, that's what a server, for example, can offer data only over HTTPS and not over HTTP, so they can say, we know that no app, no matter how crappy it is getting this transmitted in plain text. And that's true, but I'm not aware of any way for the server to know whether you are validating credentials, validating certificates. The server doesn't have any way to detect that you let a man in the middle feed you a fake certificate halfway down. Not that I know of. And so not much they can do about it. The apps have to not be stupid. Anyway, that's the plan. So that's the game. Like I say, you send your user agent to the authorization endpoint. It then gets a password from the user and sends it up. In theory, the client app cannot access the password unless you have been foolish enough to put your user agent in your app, which some of them do to make it look prettier. Anyway, all right. You can redirect this thing. You could have some kind of DNS poisoning or man-in-the-middle attacks that redirects you to other sites. So if you don't check your URIs, you might be sending the password to a malicious server, getting it stolen, or getting your token sent somewhere foolish. And there's one more called the implicit grant type, which is a small variation on the previous one to be a little more secure. One problem with the previous one is that you were sending credentials like a token in the URL, or you could be, and then it would be stored in the favorites in a browser and in the history files and log files for the web server. So what this does is it puts the token in a fragment. Now a fragment is just part of a URL. Here's a fragment. If you go to my web page and you click on the link that says projects, it doesn't go to another page, it goes partway down this page. That's called a fragment, the part after the pound sign there. You can have a URI, which has got a protocol, a server, then a folder, then a file name, and then a fragment, which is a location in that file. And the point is, if this is stored in a server log as a URI, the fragment is not stored. So putting the token in a fragment means there are less copies of that token just lying around everywhere. This is a similar issue to Microsoft's pass-to-hash attack. In Microsoft operating systems before the very latest one for enterprises, Server 2012 R2, had the effect that the domain administrator logs in here and logs in here and logs in here. There's just copies of the hash value for the domain administrator all over the place, and you can steal it. And the modern system is sort of like this, where they avoid leaving copies of that hash all over the place as the data is flying around on the network. So that's the game. The server sends JavaScript to get a token, and the intermediate servers cannot see the data stored in the fragment. So technically, the token is not shared by as many separate entities this way, and it's in principle more safe. As I'm saying, in practice, I would be happy if we could even get like half of the people to go here. As far as I can tell, everything I look at is just doing this. It's really pretty much a sin and a shame. If they're not doing that, they're doing this, which is essentially what your browser does, where you log into a site and it stores a cookie, so you don't have to log in next time you've got a cookie on there. It just doesn't exactly store your password, but it totally did pass your password through the browser. And these alternatives are available and just shockingly not used very often. Anyway, all right, so there's general threats here. None of this forces you to use TLS. In principle, you could do all this over HTTP. It's not intended to address that issue. You, of course, should encrypt it, but the purpose of this was to prevent you from having to handle the password. So that's an issue. You should be using TLS, of course, so that people can't sniff these things, and also so you can identify the servers you're talking to and not be fooled by fake servers. You can do cross-site request forgery. If I trick you into visiting a malicious site, I can put something in the URL with code here that will steal a token. And then I can reuse the token. Now the token could have anti-CSRF measures, like the token is cryptographically related to something like your IP address. So if I copy your token to another machine, it will recognize that it's not valid in that context, but a lot of people just don't bother with those. The server side, of course, has a bunch of tokens and credentials on it, and if people are attacking the server, then it will matter if the server has actually properly hashed things that should be hashed and encrypted things that should be encrypted and so on. In general, access tokens have too many privileges. For the convenience of the end user, they would like the token to give them complete access to the server and never have to type in their password again, ever. Like Dropbox. This was considered a big scandal about 2 years ago when people said, Dropbox tokens last forever. You know, you install Dropbox, it never asks you your password again. There's a file on there like a cookie. You can just steal that file, put it on another machine, and totally have another copy of everybody's stuff, and you will never know this happened. And it said, well, in retrospect, this should have been obvious. You never put in your password, so it stored a file on there, and that's an issue. But anyway, it's the same thing here. So it's best to have the principle of least privilege, where your token has limited privileges to do whatever you put it for and can't be used for other purposes. But in practice, just like all sloppy developers, it's easier to just log in as root for everything, so you don't have to worry about it. Tokens tend to have too much. Tokens don't seem to expire very fast at all, even for financial apps. It's pretty gruesome. And one thing I found for about half of the online services I tested was that when you log out, it does not invalidate the old cookies. So if I steal your cookie and you figure this out and go change your password, it doesn't do any good because my old cookie keeps working forever. And there's nothing you can do but delete your account to make the old cookie quit working, which is rude. In my opinion, the logout button should invalidate all outstanding cookies, Or there should be another button under it called Super Logout that does that, which is, I think, what they have now, like Twitter and Facebook. And I know Twitter, you can go to a page that says, how many apps have I authorized to use my account? Because if you use Twitter, you can get these things that tell you how popular you are and how smart you are and count how many people you're influencing with your tweets. And pretty soon you've got 100 other services using your Twitter account. And there's a place where you can see what they are and turn them off if you begin to worry about what's going on. I think this is a lot of how people get hacked. There are all these third-party services that have the right to post tweets on their behalf. But anyway, yeah.
Do you have the right to view activity that those apps have done within a certain period of time?
I don't think they give you that. In principle, they could. I know Google gives you who's been logging into your account. And he's even sending me emails now. If I go to a coffee house and log in, it says, someone at this coffee house logged into your account. Oh my God, oh my God. I said, well, I kind of appreciate you telling me, actually. But so if someone in China starts logging into my account, I will presumably see some emails telling me that. That would be useful to know. So it's improving. Anyway, but like I say, a few of these big leaders like Google and Facebook are really doing this stuff. The people that I think really ought to care most, like the banks, are just doing nothing as far as I can tell. They just, I don't know what their problem is, but somehow, I guess data security is just not much of an issue for them or something. Anyway.
Sure.
Seems not to be. They have some other problem that worries them more. I know they didn't even use HTTPS until about 7 years ago. They used HTTP with an HTTPS button on them. Every bank did. And when I contacted them, they all had the same memorized lie to tell me. You could Google why this is secure and get the same paragraph for every bank, which was totally false. But some lawyer had told them that was good enough, and they all believed it for a while. Then I think there was a law changed, and they all suddenly switched to real HTTPS. Yeah?
I think some part of it here is moral hazard, where one party can take an action or not, but it's really the other person, the customer, who pays the consequences. So they have less of an incentive to care about it than the customers themselves.
Yes, I think that's right. I mean, the question is, are they really held accountable for it? And I mean, for example, HTTPS, the main problem with putting an HTTPS button on an HTTP page is I can put up a fake page and it looks exactly the same. So I can send you an email with a fake link that is not really your bank, and when you click it, you go to a page that looks exactly like the bank. But the problem is, that is not the bank's problem. They are not liable for that. They were nowhere in the fraudulent transaction. You clicked a link that they did not send you and went to some page that was not them and gave them your password. The bank doesn't care. It's really not their problem. I say, you should be protecting your customers. And I say, dude, that is credit unions that care about their customers. Banks just want your money. Customers are just expendable units from whom to shake money out of. You know, corporations are not there to serve you. They are there to exploit you.
The same thing, though, could happen if the bank is using the security processes and HTTPS, because you could still get a link that leads you to a bad page.
You could, and that's why it's a huge argument. So people are now you wouldn't if you used Chrome, because Chrome actually knows the top 1,000 websites and whether they should be secure or not. And so it would actually not let you log into that insecure page because it says this bank should be secure. So it's coming. We're beginning to get over that hurdle, but we're in the early stages of it, and the people who use Internet Explorer, they're hosed. Anyway, so, although IE protects you from other attacks. All right, IE recognizes known phishing sites and warns you, so that's another issue. Anyway, which one of these is the human being? Those are the OAuth entities. All right, I'll quit at 25. All right, the owner is the human, not the client, which is what my first thought was. This is sort of like Microsoft. You know what a device is in Microsoft? It's not a piece of hardware. It's a software object connected to the hardware. We'll be going through the mobile device. The device is the printer object created. It's listening on an API socket. The printer is hardware, and that's not in the model. So you learn these things. Where's the mobile app? All right, looks like I got some answers. I'll quit at 20. All right, that is the client. The client end of the client server. There, people know that one. Good. All right. All right. So which OAuth grant type uses the pound signs? Guess I better wait till 35. All right, and that is what's called implicit. Implicit grant puts information in the fragment so less copies of it are preserved as it flies around the network, and that is in principle safer. All right. All right, which OAuth grant type sends passwords directly from the client to the server? All right, I'll quit at 30. All right, and it's E. There's 2 of them that do that. Not a very popular answer. But these are the 2. And let's go back to it. Since when I see a thing like that, that's a little bit troubling. So back here, there are the 4 types. And here they are. The first type, you type the password in and the client stores it. The second one, you put the password in and the client uses it temporarily and then lets go. And in both cases, the client gets the password and sends it to the server. So both of them require the client to handle the password. All right. So it was this one. All right. All right. Which one prevents tokens from appearing in web server logs? I'll put at 30 or 9, whichever comes first. All right. That's the implicit one with the pound sign and the fragment. That is the point of it. It hides it from the web server logs. Yeah.
Is it not in the URL?
Apparently, it might not be, but it might still be stored. Apparently, the fragment is not even sent to some of the servers in that system. They fetch something with JavaScript and they get it without the fragment. So that's the point. There's like 4 entities in the diagram, and one corner of it never even sees that because it requests it over JavaScript.
The implicit one is the one that is in the URL, right?
Yeah, implicit is the one that has the pound, the fragment.
So in that case, wouldn't it be?
The fragment supposedly does not appear in web server logs. I haven't checked. It's a good question, though. I'd like to check the logs and see. I wonder how true that is.
If you have an HTTPS request,
yeah,
does the URL appear in the log?
It does, but the fragment is not part of the URL. It appears in that part of the browser, but it's technically not part of the URL. All right, anyway, that's my understanding of it. However, you guys are encouraged to test it out and prove me wrong. You'll get extra credit if you prove me wrong. So, all right, Facebook lost all their passwords to a SQL injection attack. What did they do wrong? They also had a master database, and the master administrative password was happiness, with no numbers or anything. And they were sued for that on the accusation that this did not meet. They had somewhere in the terms of service, they said, we take reasonable measures to protect your data. And they said, that's not reasonable measures to protect our data. Anyway, I guess I'll quit at 140. That was quite a few years ago. All right, what they did wrong there was SQL injection. I'm confused. This looks pretty stupid. Oh, improper storage, okay, is the only thing you say. Yeah, they stored their stuff on a server with a vulnerability for SQL injection. Okay, I'm getting there. Yeah.
Well, I think the real issue here is storing passwords. They should be storing hashes only.
That's correct also. Yes, they all said the password stored in plain text, which is wrong. They're both bad issues. You store your thing on a server that has a backdoor into it by vulnerability, and you store them in a way that can be reversed. Yeah, that's right. All right, good. And one more. Which one of these violates the principle of least privilege? If you took your Security Plus, there are half a dozen fundamental principles in security, and this is one of them. All right, I'll quit at 25 or 9. All right, and that is overly scoped tokens, where your token gives you more privilege than you need. All right, good. All right, so that's it for this.